Hello, I'm HomoArrosor. Let's get right into it because today's explainer builds directly on the critical structure we covered in our previous exclusive lesson for members. Tracking RoboPay revealed Google, the crucial connection between Boston Dynamics Tier 1 and Pi-node. In that lesson, we established the initial framework, but as of right now, in August 2026, we have the absolute confirmed reality. The newly verified actual code and model lineages of axes and physical intelligence are out in the open, and they have made our previous analysis an unshakable, verified reality. The logical foundation we built on is now absolute. Today, we're going to break down exactly how scattered robot data, Google's inference engines, Pi-node's peripheral computing, and RoboPay settlements all operate together as one massive unified system. The pieces are all here, and they are fully connected. Look closely at this statement, because this is our definitive starting point for this entire explainer. We are no longer dealing in theories. We are looking at the complete functioning architecture of the new robot economy. It is a mathematical and technical impossibility for one single corporate entity to build the data collection, the cognitive orchestration, the physical actuation, and the decentralized financial settlement completely from scratch all by themselves. It just doesn't work that way. Instead, what we have uncovered is a flawless synchronization of highly specialized layers. These separate pieces have securely snapped together through open source code, standardized API handshakes, and verifiable technical dependencies. This is the absolute master blueprint, functioning right now. To really grasp how monumental this is, we need to methodically walk through the exact logical sequence of this master blueprint. As you can see, it flows in very distinct, necessary phases. First, the entire engine starts with the Axis v1 release, which completely solves the fatal industry problem of data starvation through crowd simulation. That data doesn't just sit there, it feeds directly into the π0.5 model via OpenPi. And that is where we see the transition to physical intelligence, which traces a direct, undeniable Google lineage right back to PolyGemma and the high-level cognitive orchestration of Gemini Robotics ER2. But to actually handle this massive intent inference, we absolutely require three-tier computing. And that exact requirement necessitates the Pi-node Edge Gateway, specifically utilizing Solohost and Gemma models. From there, the edge connects down to the physical hardware via the OpenMind OM1 operating system and Fabric identity protocols, which instantly triggers the RoboPay financial layer. And how is that settled? It is settled exclusively in Pi payment. That flawless sequence, from Axis v1 all the way to Pi payment, is exactly what gives birth to the complete robot economy. Let's break down each of these massive pillars. Section 1. The Axis Data Engine. On August 6, 2026, we saw a monumental release, Axis Dataset v1. For years, you have to understand, the robotics industry has suffered from a fatal, crippling bottleneck known as data starvation. You simply cannot train a robot to do the dishes in a million different kitchens when you only have training data from 3 specific kitchens. The environment's too rigid. Axis definitively solved this problem. They built a system where everyday humans simulate robot manipulations right inside a standard web browser, and the system automatically converts those crowd simulations into actual, highly usable AI training data. Now look at the exact progression on this table. Axis took the open-source base model from physical intelligence, the Pi.5 model, and ran it through continuous pre-training using this brand new dataset. They tested it on the Libro Plus benchmark, which is the gold standard for measuring a robot's success rate at diverse tasks. The base model originally sat at an 83.9% success rate. By injecting just 25% of the Axis data, it ticked up to 84.7%. At 50%, it hit 85.7%. And when utilizing 100% of the Axis dataset, the success rate skyrocketed to a massive 88.8%. Contrast that with the bottom row. Using the exact same volume of standard RoboCasa data only yielded a 57.5% success rate. Let's just pause on this exact metric, 88.8%. That number proves an absolute foundational reality about modern AI training for robotics. It is definitively not just about the sheer, massive volume of data. If it were just about dumping petabytes of data into a model, the standard RoboCasa data would have performed much better than 57.5%. The true catalyst for generalizing robot manipulation is the diversity of human-generated crowd data. Because real, unpredictable humans were in their browsers creating slightly noisy, highly varied task executions, the AI learned how to handle diverse environments, sudden lighting changes, and novel camera angles. Diversity beats pure volume every single time. Section 2. The Google Tech Lineage. So where does physical intelligence actually come from? We have to map this exact technological lineage because the connections are undeniable. The founders and the core researchers at Physical Intelligence hail straight from Google DeepMind, Stanford, and the UC Berkeley robotics ecosystems. These are the very minds behind Google's foundational RT1, RT2, and RTX research. But the connection goes far deeper than just personnel. It is embedded directly in the actual open source repositories. The official documentation proves that the Physical Intelligence π0.5 model utilizes Google's Polygemma as its vision language model backbone. And Polygemma itself is deeply rooted in Google's Gemma and Siglip architectures. The dependency pathway is totally clear. Google's Polygemma serves as the structural backbone for Physical Intelligence's π0.5, which is then continuously pre-trained and refined by the Axis dataset v1. Pi is the factual technical successor to Google's most advanced robotics research. Section 3, Gemini Orchestration and Inference. Now we reach a critical divergence in modern robotics, the separation of powers. We are absolutely no longer living in an era where one single monolithic brain handles everything, from recognizing a coffee cup to calculating the exact torque required for a mechanical joint. It's too inefficient. As you can see illustrated here, we have the high-level brain, which is Google's Gemini ER2, acting purely as the orchestrator. Then we have the low-level body, which is Physical Intelligence's π0.5. Google officially launched Gemini Robotics ER2 in late July 2026, and they defined it explicitly as a high-level brain for robots. Its job is completely separated from the hardware mechanics. Its job isn't to move joints. Its job is to understand intent, decompose massive tasks, and hand over the actual physical execution to the lower-level models that actually control the hardware. When Google talks about inference in this specific context, they're not talking about calculating how many millimeters a gripper needs to close to pick up an egg. They're talking about the absolute mastery of intent inference and task graphing. Look at these capabilities. Imagine a single robot receiving a voice command to clean the house before guests arrive. Gemini ER2 understands that abstract human intent. It instantly assesses the living room environment. It divides the primary goal into semantic subtasks, like assigning the dishes to the arm and the floors to the vacuum. It allocates the right machines to those specific localized roles, calculates optimal paths, and monitors the entire execution fleet to instantly correct failures. It is macro orchestration. Gemini ER2 is the supervisor, not the laborer. Section 4, Pi Node Edge Gateway. But here is where centralized AI models hit an absolute impenetrable brick wall. Streaming petabytes of uncompressed video and sensor data from billions of physical robots up to Google's central cloud servers is mathematically and economically impossible. Let's look at the actual numbers. Just 4 standard cameras on a single robot generates 6 gigabytes of data per second. If you multiply that bandwidth by 1 billion robots deployed globally, you create impossible latency issues, catastrophic bandwidth costs, and massive privacy violations. This diagram perfectly illustrates the absolute necessity of a 3-tiered distributed computing structure. We cannot rely solely on the robot's internal chips, because putting a massive $50,000 AI server chip inside every cheap delivery drone destroys the basic economics of the hardware. Therefore, a peripheral edge node must exist right in the middle, between the central AI in the cloud and the on-device robotic execution on the ground. Let's walk exactly through this 3-tier hierarchy, because it is the backbone of the system. Down at the base, level 1, we have the on-device vision language action model, or VLA. This handles instant reflexes, physical balance, and local motor control, completely without needing an internet connection. Moving one level up, to Tier 2, we have the peripheral edge node. This acts as the localized trusted gateway. It takes those heavy 6 gigabit video feeds generated locally, strictly filters them, strips out all the private visual data, and creates a lightweight compressed semantic summary. Finally, at the top in Tier 3 is the central AI orchestration. The edge node sends only that tiny, summarized text prompt up to Gemini in the cloud, which does the heavy macro planning and sends the master plan right back down through the gateway. And this architecture reveals the factual reason Pi Network has been meticulously measuring CPU cores, hardware threads, and uptime for over 420,000 active nodes for years. Pi Node, combined with the newly released Solohost framework, acts exactly as this critical peripheral edge gateway. Solohost is built specifically to allow local AI agents, explicitly utilizing Google's Gemma models, to run directly on these distributed nodes. The nodes sit in the home or the office, they compress the robot data locally, they mathematically strip the privacy risks, and they act as the essential bridge connecting the local physical environment with the central Gemini intelligence in the cloud. The Pi node is the mandatory missing link in the data flow.
Section 5, RoboPay and Machine Identity.
Now, how does this entire massive hardware and software stack sustain itself economically? It requires the financial layer, which is the RoboPay pay-to-actuate loop. In August 2026, the Fabric Foundation explicitly announced Pi Network as a RoboPay settlement partner. Through protocols like Fabric, physical hardware is transformed from passive metal into independent economic entities. Robots now possess verifiable cryptographic identities on the blockchain, and they can mathematically set their own prices for their physical services. Before a robot executes any physical actuation, the system strictly requires a Pi settlement through RoboPay. Nothing moves until the payment is cleared. Here is the perfect closed-loop economy in action, step by step. First, a human commands an intent. Second, the Pi node edge processes and filters that request locally. Third, Gemini in the cloud orchestrates the high-level master plan and hands it off to be OpenMind OS. Fourth, the Pi 0.5 model takes over for the actual physical execution by the robot. Fifth, the exact moment the task successfully completes, it is instantly settled in Pi coin via RoboPay, which automatically rewards the node operator, the hardware owner, and the Axis data creator. And sixth, the failure or success data is fed right back into the Axis data engine for continuous learning. Every single participant in the stock is compensated natively, which drives the entire autonomous system forward continuously. Section 6, the complete robot economy. When you zoom out and synthesize every single component we've covered, a massive structural truth emerges. A monolithic tech giant owning every single piece of the stack is completely unnecessary. Through standardized API handshakes and open protocols, these highly specialized layers have naturally and perfectly aligned. Take a look at this master blueprint because it represents the ultimate conclusion. It is operating as a perfectly functioning end-to-end autonomous architecture right now. Human intent is securely authenticated via Pi. The Pi node and local Gemma models handle the massive peripheral filtering. Google's Gemini ER2 executes the high-level cognitive planning. OpenMind OM1 translates that plan down to the hardware level. Physical Intelligence's Pi 0.5 natively drives the physical actuation of the motors. RoboPay immediately settles the economic value directly in Pi. And finally, Axis securely loops the physical data back into the system for continuous AI training. It is unified, and it is absolute. So I leave you with this highly provocative realization. As billions of AI-driven machines activate globally across this exact architectural framework, who actually holds the true power in this unified system? Is it Google, the central brain that orchestrates the macro logic? Is it physical intelligence, the physical body that executes the raw movement? Or is it the Pi network, the decentralized edge gateway that authenticates the humans, strictly routes the localized data, and controls the very currency that pays for the physical action? The balance of power in this new robot economy is undoubtedly the most fascinating dynamic of our era. Keep studying the blueprint. I am HomoArrosor, and I will see you in the next explainer.